Okay. So today we are going to be going through the end-to-end DevOps automation. But before we go there, I'd like us to examine and evaluate how business methodologies or business processes has evolved over time. Now, we have what we call the traditional waterfall method. And because when we talk about DevOps, we are actually, DevOps is a combination of two words. DevOps, we have, development and operations. So it's actually a combination of two words. How do we develop software? And how do we get those software deployed by operations and managed accordingly so that companies can realize their objectives of time, scope, and cost? It has become increasingly important that companies should innovate, companies should improve, to get to something that can be able to deliver high value to the organization. Now, before now, we used to have a traditional method of developing softwares in organization or developing applications. So when we look at that particular method, we have what we used to call the waterfall software development life cycle. The waterfall software development life cycle. And in this particular approach, we realize that we normally start with what? Requirements. In this cycle, you have what is required by the organization. What do they want to do? For example, let's assume that, let's take a case study for this, our stuff today. I would like us to take a case study on a company like PayPal, because I'll actually do a demo on that in course of this presentation. PayPal is our client. PayPal has contracted, our company. And who has PayPal contracted? PayPal has contracted my landmark.tech. That's what PayPal has done. They have contracted us. They want us to develop a software for them. Maybe they want a software where, client can be able to easily connect or attach their account to their My PayPal account. When you create an account on PayPal website, you have the option to either add your credit card or you add your bank account details. So now, I want us to understand the reason behind all of this, so that we know where we are going to today. So now, PayPal is our client. PayPal contact my landmark.tech. Landmark.tech is a company that develops softwares and applications. Okay, develop us an application in which when customer create an account on PayPal website, PayPal, now if you create an account, you should be able to maybe link that account easily, that is attach your credit card easily to that account. So that is the software we are going to be doing today, which is a real, work case scenario. Now, we are going to look at the different approaches that this could be done. The first approach would normally be the waterfall approach. If landmark.tech, God forbid though, that we use this kind of approach, but if that's the kind of approach that was being used, what are we going to do? We are going to start with requirements. And in this phase, our technical team is going to discuss with the paper. Paper is our client. Okay, they will discuss with the client to get to know what do you require from us? What is it that you want from us? They will normally inform us that, okay, we want this application that is going to accomplish these tasks. Now, in this same waterfall approach, once we have that, what do we do next? We are going to move to a next phase, and that next phase is going to be a designing phase. So we have gathered requirements. We have spoken with our client. Our client is paper. Paper has informed us that, okay, kindly give me an application, design me an application that will enable client that with one click, like this is my PayPal account, this account should be connected with my bank. Look at something. If you look at this account, you see the bank account and card, right? So what can I do that with one click, the application is going to work in the back end. Please take note about this word because we are going to see this word throughout this course. The application will work in the back end that when you run one click, okay, it can connect my account, okay, my PayPal account to my bank account. That is what we want to achieve. And that is why we have been contacted. So what do we do at the designing stage? What we are going to do here is that at this particular stage, we are going to do what we call high-level documentation. Requirements, okay? We are going to come up with high-level documentation and specific requirements. What do we require to be able to achieve this process? That is the next thing we are going to do. Okay, we are done with the design stage. We have documented everything that is going to be needed. So we have to proceed now to the next phase. Let's look at what happened in the next phase. The next phase is going to be an implementation phase. Implementation. Yeah. What happens here at the implementation phase is that this is actually the development phase. This is where developers will write what we call code. They will write their codes. That is, they will write the program. Okay, we call it code. The developer will call that code. They will write code, different code, that is going to be programmed in such a way that customers can integrate, their PayPal account to their bank account or can attach their credit card to their bank account. So please take note. So this phase is going to mostly be what we call the development phase. This is the development phase of this process. So take note, very important. We are going to see, it's very important for us to understand this, this traditional approach to better appreciate what DevOps is all about so that you know the right thing to study. So at this stage, we write what we call source code. We write our code. Okay, and this code, we are going to see very soon that we have different languages that we can use to write the code, like JavaScript, Java, Python, Shell script. So those are some of these, programs that we can use to write our code at this particular phase. Now, after this is done, code have been written. Okay, we have gathered all what we needed to do. We have done designing. Next, implementation. The next point is going to be for us to test, carry out testing. That's what we are going to do in this next stage, testing. we have to test our code, and that's why, you know, in organizations, we have people that are in charge of quality assurance. Our quality assurance team will run a test to ensure that what was developed or the code that were written here, they meet certain, you know, certain requirements. And if that state succeed, the next state, they are going to proceed to deployment. They have to deploy this particular code that they have written. And in this case, our case study again is still paper. So we'll tell paper, your product is ready, it is deployed, you know, to the client. Now, this is the traditional approach that it used to be done following a waterfall process. What is the challenge in this approach? Now, we are going to realize that as far as this particular approach is concerned, you know, one of the greatest challenge here, it gets to do with the resource utilization, because, you know, the resource utilization here is very poor. Why is it poor? It is poor because when we are carrying out these tasks, right, we have different teams. We have different teams. Okay, now when designers are doing their designs, for example, the people in charge of testing, they are what? Idling, which therefore implies that the slack time in the company is very high. Therefore, one of the major limitations here is we have low resource, let me keep typing, resource utilization. So this becomes a major challenge, how our resources are being used. It is very poor in this approach. We have staffs that are going to wait, you know. One other challenge is that the process to overcome this entire task can take maybe 2 to 6 months. You know, so big, which is a serious challenge. Because of this, okay, companies now have to look for another solution. What can improve this particular approach of delivering software to clients? Because paper needed a software from us. This process alone can take 4 to 6 months before we deliver it to them. And if there is a bug, if something is wrong, okay, they have to still go through this same process again, which is a serious, you know, drawback as far as a normal flow of any organization is concerned. For that purpose, when, you know, companies had to migrate, okay, to the agile method, agile methodology. Here we are going to look at, you know, the Scrum model in particular. I know we have a couple of Scrum masters with us, so we are going to look at the Scrum model. Now, with the Scrum, with this particular approach, right, companies now can be able to break down this cumbersome process, okay, into what we call iterations or sprint. Okay, so now these iterations, right, it could last for a period from like 1 to 4 weeks. Please, I am not going to be doing so much demo on whatever traditional approach or Scrum. I just want to do a, to see how we have evolved from traditional to the Scrum, and now DevOps. So now we realize here that, there is, projects are now being done following what we call, iteration. And each iteration can last for like 1 to 4 weeks. 1 to 4 weeks. Now, what is the challenge here? The challenge here is that whenever a task is being carried out, we have different set, or we have a team, and that team comprises of who? It comprises of a Scrum Master, developers, and a product owner, who is in most cases our client. And remember, our client again is still paper. Paper is our client. That's our client there, which is paper. So paper is our client in this situation. So we are saying that we can have a team of like 5 developers. We can have a Scrum Master. A Scrum Master and the product owner, which in most cases, as we said again, the product owner is the client. That's the product owner here. So we have 5 developers, a Scrum Master, and a product owner. Now, this team may equally comprises, so when they develop their product, right, they have to wait, okay, for it to equally go through the testing phase. So we have like first sprint or first iteration. We can just call it sprint 1, Maybe I should use text boxes here. So now you have the first sprint. As we said again, this sprint can last from 1 to 4 weeks. So for each sprint, right, one thing that happens is that the team velocity, everybody is involved, which implies nobody can be off work for whatever purpose. Okay, now, but which therefore implies that even if you were not involved in a particular phase, you still had to be present. As such, the way softwares were being deployed, okay, did not really meet a modern method, as we are going to be seeing shortly, with our advanced method of deploying softwares using a DevOps automation pipeline. So please take note. So these are some of the lapses as far as this particular procedure is concerned. The team velocity had to be 100%, and even the time to, the time, right, that they took, okay, was still a problem. Because here you could be able to do what? Deliver a particular software, develop an application, maybe within 2 months. Okay. However, you were tasked to deliver portion of that particular applications within 1 to 2 weeks, which therefore implies that for each sprint, okay, if, for example, remember that we want to design a software or an application that should enable an easy integration of what? For us to be able to attach our PayPal account, okay, with our bank account. Now, that whole process will normally go through these traditional phases, okay, but now, you know, with the Scrum, we could just group like requirements and design into a particular sprint, okay, and you know, we carry out this particular task together. We group the second two, okay, and we group the last two, okay, because here we're equally supposed to have one more state here, maintenance phase, okay. So we could group them into, you know, each iteration and execute them within those particular time bound. That is how, you know, this particular approach had to be accomplished. All of this again took so much time as far as the organization is concerned. For that purpose, you know, companies had to, you know, look for better means, you know, to have, because look at something. Now, when we look at the DevOps cycle, we are going to realize that this particular process, okay, follows a kind of CI/CD pipeline, a continuous integration and continuous deployment pipeline. Because when you click, you know, to link your bank account to this PayPal account, okay, you know, in one click, that transaction is going to go through the entire process to make sure that your account is attached without any human intervention. Therefore, there was a time where project managers were in high demand. That was when we had stuff like this traditional approach. You know, if you were a project manager, it was a big deal. Now they migrated to Scrum Masters. You know, Scrum Masters, you know, for you to be a Scrum person, you know, it became a big deal. But today, companies have moved from this traditional waterfall method to Scrum, and now they have advanced to DevOps. And that is going to be the focus, you know, of this session this evening. You know, how this advancement has been able to help organization. So we are going to look at an end-to-end DevOps automation pipeline and how that can be easily accomplished in any organization. And now we are going to equally understand why, you know, DevOps skills today is highly sorted for and highly rewarded if you understand who you are as a DevOps engineer. So let's, okay, now look at something. With this particular DevOps phase of a project, right? Remember, we have this particular word is separated into two. The first part of it is DevOps, developers, development, and the second one is operators or operations. So it is trying to see how we can merge, you know, developers and operators or operations together. The reason is because with the traditional approach, it used to be a serious challenge when code, Because when developers write their code, most of the time, developers cannot integrate those codes in their own working or in their own production environment. Okay, so now, you know, they have to come out with tools that those code can be easily integrated and we can have our tasks accomplished with relative ease. So let us proceed and see how we can link all of this together. How can we link this, you know, all of this together? That's what we are going to be looking at. Now, let's say we have in this company, we have 5 developers. We have a team of 5 developers. Okay. Now, we have 5 developers in this organization. Now, what happened is that these developers write their code. That is what they do. They write their code, and when they write their code can be written in different languages. And we are going to understand those as we go through this entire DevOps course. You know, and that code can be to be able to accomplish maybe a, you know, as a matter of fact, it can be in, you know, Java. So we have, let me count. Now, when they write their code, right, this code can be a JavaScript. So it can either be a JavaScript. Maybe you want to write an application for a particular database. Okay, so we write, you know, db utils.java. So this code is a particular database code. Now, remember that we have a client, and that client is PayPal, okay? Our target is this code should be deployed to PayPal so that PayPal should have this application, because what we are building is an app, is an application. That application is going to our client, who is PayPal. So PayPal is our client in this situation. So now, normally, when we write this code is going to go to a particular server, okay, called JBoos server, because codes are saved in that particular server. So we call that server JBoos. Okay, and the client that is involved in this particular, that client, remember we said our client is still PayPal. So PayPal contracted us to write them a code. We have realized that, you know, the best way to accomplish this particular process, okay, you know, is not the traditional approach that may take about 4 to 6 months, or the, you know, the agile approach that could take, you know, 2 months plus. You know, we need to have a more advanced approach, and we are going to realize that, you know, the best approach to use is going to be a DevOps methodology. This DevOps is equally a methodology, like we have the traditional waterfall and the agile methodology. So now, developers want to write this code, and this code is going to the client, okay, and it is going to be stored in a server, and that server, we call it JBoos server. So please take note. Okay, now look at something. For this code cannot just live from the developer to the client, okay? It cannot just live from our side, okay? It must go through some testing. And these guys will write several codes. You know, maybe we have, you know, this other developer B is writing one more code, maybe on how the users can be able to access this particular, you know, app. That code equally is a Java code. We call it user user.java. User.java. So that is what, let me make it to be bold so that we can see. Now, so this code is supposed to get to our client. Let's assume that the test developer writes a code this time, which is in a shell script, a bash shell scripting language. Okay, that code is to deploy this particular application. We call it deploy.sh. Please, we are going to come to realize that, you know, bash shell scripting, the end of bash shell script ends with .sh. Okay, now, how do we integrate the tasks of all these developers when they write their code? How do we manage, you know, this particular code process? What we do in DevOps is that, you know, we use a kind of a local, or we use a remote repository, okay, which can either be GitHub, okay, GitLab, or Bitbucket, or AWS code commit. So please take note. So we are just, so we have here, okay, we have, so now these developers wrote their code, and this code is supposed to be, it's supposed to be committed. So it comes here. Inside here is going to be GitHub, GitLab, or AWS code commit, but I'll just take out the AWS option. So you can either use any of these two options. Okay, here you have GitHub or GitLab. So this code is going to be committed in this particular remote repository. It will be committed in this particular remote repository. Okay. Now look at something. Now, why do they have to commit their code to a particular remote repository? Reason is simple. We realize here that we have 5 different developers. Okay, now if this other 2 wants to, you know, maybe add to what was done before, now it is not a good practice for you to write your code and share the code with any other person. That is not best practice. So you have to commit the code, and if somebody wants to add, you know, a modification or new version, this person will need to come to this local repository. Let me just indicate that this is a repository. Okay. This is a repo. Okay, so this is a local repository. So if developer 4 wants to add something to this code, for example, he would need to pull the code, okay, and write, you know, and write from this local what repository, okay, and that will now be merged, okay, you know, for easy what access, and for them to get the best possible result as far as this particular code is concerned. So please take note. So now we have developer 4 can pull it from there. So we have the other guy, the feed guy also can carry out so this guy also can pull the code from there to do any modification. Now, when they carry out this particular task, the next thing that is very important is that this code, okay, you know, this, remember, GitHub here, okay, is a local repository. So all the codes are being saved inside here. So now, you know, but when the code is written, it has to go through a building, okay, process. So we have to do code build. Okay, we have to use code. Okay, now we have to do code build. This time around, we are going to use other tools, okay, you know, to build this particular code with, to build, you know, and ensure that it meets user acceptance testing. And the kind of tools that we can use here is going to be tools like Marvin, okay, and or AWS code build. So please take note, you know, we have, because that is the cloud that we are going to use throughout this course, AWS and GCP. So now we can now carry out a code build. And when this code is built, one more thing is that it is going to come out with some files. Okay, when the code is built, please, because of space, or take out the AWS option, it's going to come up with some files called jar file, okay, WAR file, and EA files. Those are the files that it, you know, when this code is built, is going to come out with. But one more thing is that when you build this particular code and these files are generated, the jar file, you are supposed to save this file in a local repository, or what we call an artifact repository. In this case, the best option here is going to be Nexus. So we are going to save this jar file inside here. Now, this is a backup because it is very good for you to know, you know, what goes on, because this repository is very important, for example, because normally, remember that the final process of all of this is for you to ensure that these files are deployed, okay, to production. And remember that our client in this case is PayPal. Now we want to deploy this client. What happens if we deploy it and something went wrong? There must be a backup. So this repository is a backup repository where all the artifacts are going to be saved. So please take note, very important. Now, a part of that, right, we need to do a code review. There must be a review in this whole process. Okay, to ensure best practice, we will have to review this whole process. And for that review to be done, we are going to need one more saver, which is very important. In that case, we are going to use the SonarQube server, okay, to do what? This is to ensure that, that here is to carry out a proper review, okay, before any deployment is done. Now, but look at something, please. In all of this process, right? Now, when we talk about this particular big guy here, DevOps, we want to see how we can integrate all this stuff together. How can we integrate, this entire or tools? How can we integrate these two together? We are going to use something that is very important, okay, an integration tool. In this case, we have different integration tools that can be used, but we are going to use an integration tool called Jenkins. That is what is going to be what we are going to use throughout this course. You could equally use stuff like Team City, and stuff, but we are going to use, Jenkins to integrate, GitHub, Marvin, Nexus, SonarQube, and every other, tool that we are going to use, okay, in this entire process. So let us get Jenkins. So we are going to now, this is our Jenkins server. This is our Jenkins server. So Jenkins, okay, Jenkins in this case is what we call continuous integration tool. This is our continuous integration tool, Jenkins. Jenkins is going to help us to integrate, all these servers and processes together. So in this case, we are going to have Jenkins will integrate with the review server. Okay, now, so Jenkins will do what? Jenkins is going to integrate all these tools that we have seen already together, which therefore implies that, look at something like, okay, it will equally integrate with the GitHub. It will integrate with the GitHub as well. This is GitHub here. Jenkins will integrate with GitHub. So look at something, please. I just want us to understand something, because what is going to be realized here is going to be a process of continuous integration. Jenkins wants to see how, we want to see how Jenkins will integrate all these services together, which implies that now we have developers here. When they write their code, they are going to push this code to GitHub. The word push is something that we have to be very abreast with when it comes to this entire process. So when they write their code, now this code is pushed or transferred to GitHub. When the code comes to GitHub, now we can program the Jenkins server in such a way that Jenkins server will pull the code from GitHub and ensure that ensures that Marvin here, build the code or and convert it into these jar files. Now this jar file, they are safe where? They are safe here inside this our, repository. This our artifact repository, Nexus, as a backup. And they are equally deployed, to production as far as this, because we want to realize, an application for PayPal. So now we are going to need one more server that will help in the deployment of this overall process. Or one more tool. In this case, we are going to look at a tool called Ansible. We are going to look at Ansible. Ansible can equally be used as a deployment tool for a monolithic application. So here we are going to have Ansible. We can have other tools. There are so many other tools like Chef, Puppet, and stuff. But in this particular project, we are going to look at Ansible. Now look at something. So here we have Ansible. So now, when Jenkins has carried out, has pulled the code, ensures that the code is built by who? Marvin. The jar files are saved where? Nexus. And then a proper review is done by SonarQube. He can now deploy the code to who? Ansible can now pull the code from here and deploy it to this particular client who is PayPal. Now, one thing I want us to realize here is that when Ansible is deploying to these JBoos servers, Ansible can deploy to a good number of these servers. And why should such a practice be done in the organization? It is simple. It is to ensure high availability and equally to ensure that, for example, if one of these servers fails, there should be a backup server, to complete the task. All these are different, JBoos servers where Ansible can deploy this particular code to. And take note, insofar as Ansible can deploy it to one server or two servers or three servers, we can configure, because Ansible is equally a configuration management tool. So we can configure this guy, to deploy this particular application after it has gone through, all the processes of code build, code preview, it can now deploy it to any number of servers. Like for example, we still have this, our case study, and in this case, it is PayPal. Please note that when you look at PayPal, we have millions of subscribers of PayPal, millions of them. So if, for example, we have like, 10,000 customers trying to access their PayPal account at once, now, one JBoos application server cannot be able to solve that problem. So what do you need? You need several of those servers. And when we proceed, we are going to see that we can equally attach a load balancer here, okay, and use other, deployment tools, okay, that will scale out these servers, which implies that, we can have more of this application being scaled out depending on the number of customers. Meaning that if we had 1,000 customers, okay, we may have like 20 servers. But if we have 1 million customers trying to access this particular application, we may have like, or 1,000 applications, okay, being made available to them. So we are going to see how, all of this process can be automated. How can we achieve, scalability and availability? So we are going to see all of this, throughout this, our DevOps e-degree program. So please take note. So now, Ansible is going to pull this guy. Ansible pulls this guy, from, Jenkins, and Ansible does what? Ansible will deploy it to all of these servers. That's what Ansible will do. So Ansible will deploy it, will deploy the application to all these servers. That's what Ansible does. So now, Ansible, with one command, Ansible will deploy this application to all the servers we have seen here. Now, what are we realizing? Something is happening here, right? We are using Jenkins as what? Jenkins, Jenkins is being used as the continuous integration tool. This is the tool that is integrating all these other tools for us to, realize what we call continuous integration, continuous delivery, and continuous deployment. We are going to be seeing that in more detail, as we proceed with this particular call. So please take note. Now, look at something. When this application has been deployed, what else do we need in this whole process? What happens if something fails? What happens if the application is not working? Okay, how are we going to know that the application deploy is not working, or something is wrong with the code, or something has gone wrong, How are we going to know that? We need to have some other tools. In this case, we are going to call those tools monitoring tools. So we are going to need monitoring tools, which is going to be able to monitor what is happening in this entire process. That's what we need. And since we are going to be going so much in the cloud, the monitoring tool in this situation, we can use stuff like Grafana, Nagios. We can use AWS CloudWatch. We can use AWS CloudWatch. Datadog, so many of them, but we'll just focus with these three for now, please. There are so many of those tools that we can use. But in this particular course, we are going to look at these three tools and one more. Nagios, Grafana, CloudWatch, and one more. We are going to look at those ones in detail because, you need to have a good mastery as far as those particular tools are concerned. So these are the tools that will inform us. So we are going to call this particular tool monitoring tools. So if something was going wrong These tools will announce to us that, okay, something is going wrong, maybe with the application. And that announcement could be through what we call alarms. Like with CloudWatch, you can set a CloudWatch alarm, for example, where if something goes wrong, okay, it can send an email notification to whoever is on seat at that time, because normally monitoring is done 24/7. It's a 24-hour service. So the guys that support this particular service, they are supposed to be, they are supposed to be available 24/7. And when something goes wrong, you can have an email notification, okay, saying that something has gone wrong with maybe with this application, okay. And from there now, once that information is received, okay, now you can use like pager where a phone call can, like the application can make a call directly, okay, to whoever is on seat, notifying him that something is wrong with the application. Maybe when a customer is trying to connect the account, okay, to connect or to attach his bank account to his PayPal account, the task cannot be executed. So something is wrong and it needs to be fixed. An email notification is sent immediately. Who receives that email notification? That is going to be our support desk. So the support desk will receive that particular email notification. Okay, and when they receive it, right, what are they expected to do? They are supposed to generate a ticket using other tools like Jira, which is very common. They can use ServiceNow, okay, etc., Remedy and stuff. So we have all these ticketing tools. So, whoever is here in charge of support, he receives notification from, saying that this application, something is not working as expected. So we also need to have this connection here as well. So we receive a notification from one of the, from this particular, JBoos server application, informing us that, clients, maybe they cannot even access their PayPal account. When they try to connect their PayPal account to their bank, with their bank account, they are receiving an error message. Okay, so the tool that should be present there are going to be these monitoring tools. So now the support team will generate a ticket, and this ticket will, if it concerns the source code, development stuff, the ticket will now be forwarded. The ticket will be forwarded to our team here. Yeah, give me what I wanted. Okay. Okay, so the ticket now is forwarded. And if the problem concerns like some kind of servers and stuff, the ticket would usually be assigned to systems administrators, working within the organization. So please take note, this is how this overall process goes through. Now, once the ticket comes back here, they are going to process it, okay, push it where? To GitHub. Once it goes here, Jenkins will pull it from there. Okay, now Jenkins with, when it is pulled, you know, Marvin will now build it, test it, and ensures that it is, you know, ensures that it meets user acceptance test, okay, before it is now being what? Reviewed by SonarQube, okay, and then saved in Nexus. From there now, Ansible will pull it and deploy it. That overall, you know, process has gone through successfully. So please take note, this is what the DevOps, you know, end-to-end automation is all about. Now, one question we may ask is, if you look at this whole process, we haven't discussed about stuff like Docker and Kubernetes, okay? And those ones are very important. There is no way you can go to any interview without Docker and Kubernetes. Please take note. Now, what we have done here, this is a good example of deploying a monolithic application, okay? A monolithic application, you know, is when, maybe, look at something, please. When you have, I think I should put an page. Okay, look at something. Monolithic application. Monolithic. Okay, now what we achieve here, okay, is deploying a monolithic application, an application that contains all the services that we need to run effectively. Now, if we were to deploy microservices, now, if we're to deploy microservices, we are going to need Docker and Kubernetes. Docker and Kubernetes become very important. Kubernetes with Docker Swarm, because Kubernetes and Docker Swarm, they accomplish exactly the same tasks. The difference is that Kubernetes can scale out several iterations, you know, far ahead what Docker Swarm can accomplish. While Docker Swarm also focuses on Docker containers, Kubernetes can, you know, run, you know, deploy different classes of container, be it Docker, you know, OpenShift, Rocket, and stuff. So please take note. So those are some of the main stuff that I want us to understand as far as this particular process is concerned. Now, which implies that if we come back here, if we were deploying microservices, for example, then where we see Ansible, okay, maybe we would have had here Kubernetes master server, and this master server would have deployed to different Kubernetes, okay, clusters, which implies that, you know, and each cluster, each of those clusters will have different number of nodes, okay? Those nodes can be like a JBoos application server, and each of those servers can have different ports. Those ports may be, you know, different, okay, microservices. So please take note, we are going to see that in, you know, great depth as we proceed with this particular course, because Kubernetes is a very important skill that you must know as a DevOps engineer. So what have we accomplished today? Let me just Now, look at something, please. We have gone through the waterfall, okay, model. We have seen how organization in the past use this particular, approach to develop their software development life cycle. We equally see how, it was important for them to move from that particular approach to the agile, okay? And importantly, we have seen how we can integrate. When I prepared this particular slide, I used Facebook, because you can use Facebook, and so here we have Ansible as a configuration management tool or a continuous deployment tool. So please take note. So this is just the exact picture which we are supposed to understand. Now, one thing I want to inform us is that when we go through this, our entire course from end to end, we are going to carry out 5 projects. And those 5 projects, if you go through them, after going through your course, it is virtually going to be commensurate to at least 4 years of working experience. Now, with project 1, we are going to, use this, we are going to use CI/CD pipeline, preparing what we call a Jenkins declarative pipeline, okay, to deploy an Apache Tomcat server. This Apache Tomcat, I know some of us may be confused with this particular word, but don't, when we go through it, that is going to be very clear. Now, here you see SonarQube. This SonarQube is the company that came out with the Nexus server. So this SonarQube here is actually Nexus. Okay, so look at something. Here we have developers, stage 1. They build their code. What do? They push the source code, okay, unit test cases were to GitHub. Now, Jenkins will pull the code from GitHub. That is step 2. Step 3, Jenkins will use what? Apache Maven to build this code. Okay, once the code is built, it goes through a code review. Once they review, okay, once it passes that test, the report is sent back to who? Jenkins, and as such, the artifacts is going to be saved where? In SonarQube. And now we can now deploy, this whole process. We are going to see how we can use Jenkins to deploy this particular, whole process in our project 1. So please take note. Now, the next project, we are going to see how we can carry out all these tasks. Okay, in this scenario, we are going to, use what here, Docker, to create a Docker file as well, which implies that, please follow me. Now, developers build their code. They push it to GitHub. GitHub is the local repository. So this is going to be one of our live projects, okay? Now, GitHub, Jenkins pull the code is built, okay? Now, after the code is built, it is review, okay? What then report is sent to SonarQube. So please take note. And, once we have that, okay, Docker will take that particular code and build what we call an image or a container, okay, to be deployed. And once everything is okay, we are going to see how we can configure Jenkins to send notifications to developers, which implies if there is any kind of failure, developers will receive an email notification. So please, this is going to be one of our projects, because most people that go for DevOps job, which I have gone as well, they are going to ask you, you could just be given a project to go and execute that project. And most of the time, the project is going to, the project will test to see how you can integrate all these tools together okay, and help your organization to automate their services and improve accordingly. So please take note. Now we have this third project. So there are actually 5 projects that we have to go through them. Okay. Now the third project, we are going to see how, once the code is built, please follow me. Once the code is built, Ansible will treat, now Ansible is going to use the code to write a playbook, okay? And that playbook, okay, is going to do what? Because what are playbooks? Playbooks are configuration files, because Ansible is a configuration management tools. We are going to see a lot of playbooks that we can do with Ansible. Okay, so please take note. Now, so these are configuration files that will pick up the code, okay, write in a file and ensures that, okay, an image is saved where? In Docker Hub, where Docker now can now pull the image and create a container, okay, and as such, email notification again is going to be sent, because, this is how a real-world scenario is usually accomplished, normally, as far as this entire process is concerned. Okay, now, the next project, we are going to see how we can use Docker Swarm, how to integrate Docker Swarm, okay, to deploy, this over, which implies that now developers build their code, Jenkins will pull the code, Marvin will build the code, okay, the code is going to be what? Reviewed. Now, in this case, we are not going to save the code in the other server that we saw, Nexus. Now, the code is going to be pushed to the Docker registry called Docker Hub. Okay, this code is going to be built and pushed, okay, to Docker Hub. And from there now, okay, we are going to use Docker Swarm, okay, to deploy that particular service. So we are going to carry out a live project like this as we go through this course. And the final big project is going to do the same process, but this time around, we are not going to use Docker, or we are not going to use Docker Swarm, but we are going to use Kubernetes cluster. So please take note. So these are the 5 projects we are going to, carry out as DevOps engineer. I tell you for free, if you explain any of these projects from end to end in any interview, okay, depending on what you were asked, you got the job. And our task is to ensure that you should be able, to give a detailed analysis as far as this particular, project is concerned. Okay. Let me go today. Okay, now, one other question that, okay, I already explained to you guys the, Docker and Kubernetes. When it comes to microservices, that is what we are going to use. We're going to see, more details as far as this particular aspect is concerned when we look at Docker and Kubernetes. Okay, now look at something, please. As a DevOps engineer, more than 60% of jobs that are available, they want you to have cloud experience. The question is, which cloud experience do you need? If you want to go and do an AWS certification, for example, which one should be done? There are so many of those certifications. It teaches and touches so many things. Okay, but what I want to explain to us is what we are going to touch exhaustively. We have 10 AWS services that we are going to look at. And these are some of them. S3 bucket, okay. These are, because now the main one here is AWS Cloud Formation. Now, what is AWS CloudFormation? AWS CloudFormation is used to accomplish what we call infrastructure as a code. Now, what does that imply? That implies that with CloudFormation, right, you can write a configuration file, and that configuration file is going to accomplish, what we were trying to do here. Remember, our main project, let me check again. Okay, now, our main project was to deliver this PayPal application, right? Remember, that was our main project. Now, the question is, how can I use CloudFormation to achieve that process? What can I do for CloudFormation to achieve that process? Now, what we can do is that you can write a particular configuration files that will contain everything that you want to accomplish. Now, that file is going to create virtual machines. Those virtual machines, as we saw here, are the application savers. Okay, it will create those machines, and it is going to deploy whatever application we intend deploying. For example, if you wanted to deploy this Apache Tomcat here, right, you can use that particular tool, okay, CloudFormation. You are going to use one configuration file, okay, and it is going to carry out this entire process for you. And that is why DevOps engineers are very important in any organization. Why? Because they help the organization to save time. We saw that when you use agile method, okay, now you deliver your processes in what we call sprint, and a sprint can last from 1 to 4 weeks. Okay, which implies that in 4 weeks, or in 1 week, or in 2 weeks, you are supposed to be able to do what? To deploy a particular code or application. But with DevOps, you can be able to deploy, this whole application, like 5 of it every day. You now see why DevOps engineers are very important, because they will help company to save time, and as such, to increase their profitability and return on investment. So please take note. This is one thing that I want us to take particular note of, and we can realize that using CloudFormation. And please, all what you see here for AWS, we are going to look at it. AWS code pipeline, virtual private cloud, Amazon, EC2, Amazon EC2, okay, Amazon, we are going to look at all of this as part of our, course as DevOps engineers. Now, one other tool that does exactly the same thing that CloudFormation does is Terraform. The only advantage that Terraform has over CloudFormation is that with CloudFormation can only be used with AWS Cloud. Okay. If you want to use this particular tool, Terraform, you can use Terraform with any cloud, be it AWS Cloud, Azure Cloud, or Google Cloud. And we are going to look at Google Cloud as well. There are 4 services we are going to use as far as the Google Cloud is concerned. We have exactly 4 services, that we are going to use for Google Cloud. So please take note. So all what we have said, okay, it follows this entire process where there is a plan, okay, we have a plan. From there, developers will write their code. The code is going to be built, the code will be tested, the code will be released, it will be deployed. We have operations and what? Monitoring. So please take note. All what we have explained, it is, is going to be achieved when we do a continuous integration with all these tools and continuous deployment with all the tools. So this is what we are going to do as far as this overall DevOps end-to-end program is concerned. The next question is, what is going to be included in this particular syllabus? What are we going to study to go through the entire course for the DevOps E-degree? Oh. Now, this we have here, you know, Linux commands, because we are going to basically work with this kind of, you know, systems, you know, Linux operating systems. So we are going to spend 16 hours here, you know, to go through that particular, you know, because I want us to have a good, you understand now, you know, understanding as far as these particular command lines are concerned, what to do with it, how to create account users, and how to automate, you know, transaction. So we are going to focus more from a DevOps perspective. Please, this is not a Linux course, so, you know, we are going to focus more, okay, from a DevOps perspective. Secondly, we are going to look at share scripting, very important, okay, how to write script to help us automate our tasks, you know, carry out tasks at specific intervals, and that will take 9 hours. Now for Git and GitHub as well, you know, how to carry out all the Git commands.
Is the quickest and most reliable way to double, triple, even 20 times. And that's such a brilliant message. Perhaps if it's difficult to be a gay man in the public eye, especially in Hollywood, I think it's probably more difficult to be a lesbian. And she has succeeded in ways which...
Okay, sorry for that noise, please. I just muted everybody. Okay, so now we have one other two again, GitLab and Bitbucket. You know, once you have understood this GitHub, you know, GitLab and Bitbucket does exactly the same thing, but we will just, you know, go through it just because if you are asked in an interview, you are supposed to know what it does. So we are going to create accounts here as well, free accounts, and see how we can accomplish the same tasks that GitHub and Git can accomplish with GitLab and Bitbucket. So please, you take specific note with that. Then we equally have Apache Tomcat that's going to take 3 hours. You know, the SonarQube server is going to take 4 hours. This other server, you know, that we saw again, you know, Nexus, 4 hours, Jenkins, 12 hours, Docker, 16 hours, because we have a lot to accomplish there. Then Kubernetes, 15 hours, Ansible, 9 hours, AWS, 10 AWS, services, 8 hours, GCP, Google Cloud Platform, we are going to have 4 services there, 3 hours, you know, monitoring tools, Terraform, okay, interview preps, resume lines, and projects. We have seen the 5 projects that we are going to do and interview questions. But note that for each section, we are going to have interview questions and answer. As the session starts, okay, you are going to have those questions and answers so that as you are going through the particular, you know, you know, studies, you should be able to do what? Go through all those questions. So please, we are going to start tomorrow, and once we start, we are going to have this particular note and questions, all what you are supposed to know here. You know, we already have them prepared so that you can have a good, you know, insight as far as this particular process again is concerned. So please take note. Here comes, you know, this brings us to a close as far as this particular presentation is concerned. Thanks for coming and thanks for being part of the presentation, and congratulations for you all. You know, I hope that our vision is that between now and December, you know, we should have 21 DevOps engineers who have gone through this particular training. So we are going to have enough support to be able to assist whoever is going to be part of us to ensure that you go through your course. If you have any issue, you can call, and our numbers are there, and all your questions are going to be solved, and we're going to see how to equally put you through, to go through your stuff completely. So please, I would like to take some question. If you have any question, you can just type it on the chat. Yeah, we have a chat box there. Just go ahead and type the question so that we can go through the questions now.
Yo.
That's good.
Any question?
Perfecto, perfecto.
Yes. I have a question.
Okay, go ahead though.
Yeah, I'll first of all thank you for giving us this opportunity. May God richly bless you.
Thank you.
My question is, with this, do you need IT background?
Oh, you don't need any IT background, because we are going to start the program from the basics, okay? We are going to go very slowly and very surely, and we are going to explain the, basics to you. That is why we have structured the course to run for 120 hours instead of the initial 70 hours that we wanted the course to run. And our first class is going to take place tomorrow morning at 10:30 a.m. So please take note. The class will be tomorrow morning at 10:30 a.m. So all those are going to be in the class tomorrow. You are going to get a full timetable on how we are going to be going forward with the course. Any other question, please?
Thank you.
Okay.
Wait, Mama is watch. Go down. Yes, wait, let me watch. Go down.
Okay.
So I have a question, Lega.
Yes, go ahead.
So how long is the class?
The class is going to last for 3 hours. So with 10:30 Toronto time to 1:30 p.m.
And the subsequent classes, how would they be structured?
Tomorrow, we are going to have a timetable for the entire course, because I know today there are people here who are not, who may not want to have to proceed, who just wanted to have an understanding on how the DevOps end-to-end pipeline project can be carried out within the organization. So tomorrow, we are going to be talking business on how to move forward as far as this entire process is concerned.
And the registration process?
Yes, so all those ones, because please, immediately you are done with the class today, you can just contact me by WhatsApp for those that plan to be with us, okay? Contact us so that we can, inform you on, the fee and, every other stuff, please. Yes, for the program. But we have one thing that you have to know is that this particular session, we have 60% discount on the fees for the first 21 persons. They have 60% off the fee. So it's very important that you discuss with us so that you have the full details and benefit fully from the incentive as well.
I have a question here.
Yes,
Thank
go
you so
ahead.
much for your time and the initiative.
Come inside and get it. One.
Is this the first session is this the very first one, or have you organized one before? If you did, what is the result of the previous attendees?
For DevOps, this is going to be the first session. For DevOps, yeah.
I see.
Mm-hmm. But one thing I want to tell all of you is that I want you guys to know that being with this particular batch, you don't have any problem. Why do I have this confidence? The first reason is that I have had a lot of interviews lately as far as DevOps roles are concerned. And, basically, what they want you to know, we are going to teach you 150% of what you need to know as a DevOps engineer. Now, I had a call on Monday. The interviewer wanted me to refer 20 people, but